Hey everyone, this is the video for lesson 9.2. It's on finding the roots in the vertex. We're still on parabolas, quadratic, equations. Hopefully class made some sense because I'm about to do a lot of calculator stuff without a calculator on the screen. So for this video, you're going to want to have your calculator out for it to make any sense. And just make sure you're paying close attention to what I'm saying, and ask questions on Google Classroom if you're confused about where to plug things into the calculator if I didn't make it clear. All right, so the roots of a parabola. So we're right here. We got a parabola. We're going to see this parabola a lot today. First, the 2 points on the x-axis are the x-intercepts, so you should know that by now. We know where it crosses the y-axis is the y-intercept, where it crosses the x-axis is the x-intercept. So a parabola will have at most 2 x-intercepts. It could have 1 and it also could have 0. You'll see more of that. So the x values of those points are the solutions to the equation f of x equals 0. So say this is f of x, like f of x equals some parabola equation. So if f of x equals 0, so this is 0. So notice that if I made f of x equal to 0, it would be where it crossed the x-axis. Now these solutions, these x-intercepts, they're also known as roots. Most people call them roots, but you'll see x-intercepts, you'll see roots, and you'll see zeros of an equation. Also, the calculator uses the word zeros. So just be prepared for those 3 words to show up. So now on to the calculator thing. So have your calculator out, be ready. So I'm going to use a graph to approximate the roots of 0 equals x squared plus 3x minus 5. When you're finding the roots or the zeros or the x-intercepts, the equation should be set equal to 0. Because that's what we said before. We said that f of x equals 0. That's how we find the roots. All right, so you're going to go into your calculator. You're going to hit y equals in the top left. y1, the first equation, you're going to put x squared plus 3x minus 5. In y2, you're going to put 0. Now, when you graph these two, you're going to want to hit like zoom 6 or change your window a little bit. Like they did 8s all around, so maybe you want to do that, but zoom 6 probably should work pretty well. When you graph this, you're going to see the parabola show up nice and pretty, like this. And if you have a newer calculator with the color screen, you're going to see that this y equals 0 line draws a straight line. It's kind of ugly, but draws a straight horizontal line through the x-axis. If you have an older calculator, you won't necessarily see it, but just know that it's there, so long as you did y1 equals this and y2 is 0. So now you have a parabola and you have a line. You can see we have 2 intersection points. We have right here and right here. Those are the roots, but we treat them as intersection points in order to find the roots. So now in your calculator, you hit the second button, then you hit calc, so that's like the 4th button on the top, I think, and then 5. So 5 should be intersect. When you do that, you're going to, once you hit 5 or hit enter on 5, you are going to be brought back to the screen that looks like this. And now you bring the cursor to one of the intersection points. So you move the left and right arrows until you see the cursor show up. It's like this little Spider-Man looking thing. And then bring it as close as you can to one of the intersection points. And that's where the parabola crosses the x-axis. If you don't have, if you don't get to see this straight line, if you have an older calculator, just know it's where it crosses the x-axis. Once you get as close as you can, hit enter 3 times. And then at the bottom of the screen, you'll see x equals and y equals. Look at the x value. That's the value of one of the roots. And then you would do the same for the others. So you do second calc 5, bring the cursor over here, enter, 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 look at the x value. Write those down. Now you should get negative 4.193 and 1.193. I round to 3, but I could see why you'd round to 2 places. It's preference, I guess. Okay, so these are our roots. They're going to be ugly for a lot of them. Some of them will be pretty though. All right, so this is where you need to ask questions on Google Classroom if you're confused on where to put stuff on the calculator. All right, so now we're going to look at the same parabola, but we're going to talk about the line of symmetry. Now the line of symmetry is this vertical line that cuts the parabola into two mirror images. So notice if I wanted to fold this over, it would completely overlap. So that's a line of symmetry. We're going to figure out on the next slide how to find the line of symmetry. All right, so we got a whole bunch of stuff here. I want to find the equation of the line of symmetry, find the coordinates of the vertex of the parabola. And this is our parabola, same one. And then we want to write the equation in this form. This form is also known as vertex form. You've seen it before in this way. You move the k over. So this is our transformed parabola. So you know this. The vertex form, you know it. This should be real straightforward. But finding it's a little difficult. So to find the line of symmetry, you want to add the two roots together and divide by 2. So our roots, remember, were negative 4.193 and 1.193. Add those up, you get negative 3 divided by 2. That's negative 1.5. So the equation of the line of symmetry is always going to be x equals, and then whatever you got for the math. So in this case, it's going to be x equals negative 1.5. So this right here is our line of symmetry. To find the rest of the vertex, because that's what we're asking, we got the line of symmetry, check. We want to find the vertex. We know the x value. The x value is right here. X equals negative 1.5, so we got to find the rest. We have to find the y. So in order to do that, you plug in the line of symmetry number into the rest of the equation. So negative 1.5 squared plus 3 times negative 1.5 minus 5. Plug that into your calculator, you get negative 7.25. So this right here, this point, is our vertex. Negative 1.5, negative 7.25. So now we can see that we move to the left 1.5 and down negative 7.25. So our equation, now you could put this over here like y plus 7.25 like we did in the last section, but I'm just going to bring it over. I'm going to make it calculator worthy. The reason I have a 1 is because that was the stretch factor in the original equation. You just look at what's in front of the x squared. So since there's an imaginary 1 here, this would be 1. X plus 1.5 because I went to the left, 1.5. And then minus 7.25 because I went down. Now it's only minus because it's on this side. If it was on this side, it'd be plus. That is your preference. I don't care either way. Just know if you were trying to plug it into a calculator, it'd have to be over here. All right, so here's your assignment. Make sure you're taking good notes. You're ready for, or you take your Google form quiz. Your mark is done, and have a good night.